Okay, in the last video we talked about the characteristics of the normal distribution. Now, I mentioned that if we sample any type of continuous data and we take a truly random sample and the sample size is big enough that it will form a normal distribution. Okay, so what this means, if you think about it, there are an infinite number of normal distributions in the world. Okay, because there's an infinite number of continuous data types, data pools in the world. So because of that, that would make analyzing each normal distribution pretty labor intensive because each one is different. So because of that, statisticians came up with what is called the standard normal probability distribution. Now, the standard normal probability distribution, it is a theoretical distribution. You won't find something in the real world that has a standard normal distribution. Like you won't find a pool of data that makes a standard normal distribution. Okay, it's a theory. You won't find it in the real world. You are expected to know that. Okay, in the standard normal distribution, it has all the characteristics of the normal, plus it has these two additional characteristics. The mean of the standard normal is always 0, and the standard deviation is always 1. You know, that makes sense because it's a theory, okay? It doesn't exist in real world data pools, so it makes sense that its mean is always the same and its standard deviation is always the same. We can also call it the Z distribution, okay? Now, I should have erased this. I'll just do a new file. Okay, as we learned in the last video, assuming that you are watching these videos in order, okay, the normal distribution, oh my god. Let's try that again. Yes, that's better. Okay, the normal distribution, it's always centered over its mean. Okay, whatever the mean of the data pool is, that is where the normal distribution is centered. Okay? The tails don't touch the x-axis. The curve is asymptotic. Total area under the curve is 1. Okay? Centered over the mean. The fatness is determined by the standard deviation. And because the curve is symmetrical, 50% of the area is on this side and 50% is on this side. Okay, so if this is a normal distribution, then we call the values on the axis, we call them x values. Okay? Maybe I should change the color now to talk about the standard normal. Okay, the standard normal distribution, it also has all those characteristics. It's centered over its mean, bell-shaped, total area under the curve is 1, it's asymptotic, the tails never touch the x-axis. Okay, the fatness of the curve is determined by its standard deviation. But remember, the standard normal, I'm just going to say ST normal. The standard normal always has a mean of 0 and a standard deviation of 1. Okay? And values on the standard normal are called Z values, okay, or Z values if you want to speak British English, which I hope you don't. Okay, so we have the normal distribution. There's an infinite number of normal distributions in the real world, okay, and because of that, it would be very labor intensive to analyze them. So statisticians came up with what is called the standard normal distribution. It's a theoretical distribution, and we use it to analyze and make predictions about normal distributions. Now, how do we do that? Well, we've got to use a formula. Okay? So what we're going to start doing, or actually what we have started doing, we use this formula, Z equals x minus mu over sigma. Okay? And this formula is on our PowerPoint. Okay, here it is, z equals x minus mu over sigma. That's how we standardize our normal distribution values. Now, z, okay, as we learned, z is a standard, oh my God, my writing is so messy with this stylus, a standard normal value, okay, whereas x is a normal value, okay? I just want to make it clear because there was some confusion in some classes. This mu, this mean, this is the mean of whatever normal distribution you're working with, okay? So it's going to change with every problem that we do, okay? Every data pool we analyze. And this sigma, this is the standard deviation of whatever normal distribution we're working with, okay? Now I say that because in some classes students said, oh, okay, so it's always x minus 0 over 1. Well, no, that's not true, okay? Because this is the mu from the normal, and this is the sigma from the normal, okay? So this is what we're going to use. We're going to use this formula to take real world values, okay, and standardize them so that we can make predictions about the probability of values being greater than, less than, or in a little bit we will start having, we could have an x1 and an x2, and we will make predictions by standardizing them about the probability of finding values between. Okay? Let's go back and look at the PowerPoint. Okay, unfortunately we're not allowed to use Megastat anymore, so really I'll just remove that right now. Okay, we've got to use what is called the z-table. Okay, and we're going to talk about that in the next video.